Swayam Prabha. Digital India. Educated India.
Our friend Nalin Dhamilia of B10, he lost his A3 sheet, in fact 2 of them. One was a blank sheet and the other one was the one that had lab 1 work. So if anybody in B10, B11 or if anybody has found those sheets, please return back to Nalin. Otherwise you can also go to the lab and see if they are there. Okay, and if not, then so the second announcement pertains to homework number 2. Okay, I've asked you to draw sketches, freehand sketches. So there are 2 possibilities. Possibility 1 is you can draw them on the respective A3 sheets. The second possibility is the sketchbook. What do you prefer? Who goes for sketchbook? Amen. Rulers, just your hand holding a pencil over a piece of paper. All right. And of course the reason is quite obvious. What's the reason? Rain. All right. But just in case if it was not raining today, okay, quite a few of you might still have come late. So this is a game that I tend to play at times. So given a word, I try to prefix an alphabet and try to make different words. Okay, so let's do this. So try to prefix an alphabet and try to make different words. E, elate. Okay, settle down guys. And then before that? No. So the game is about prefixing a single alphabet. R, late. That involves an E. A single alphabet. Right? Just a single alphabet. That's what the trick is. So it looks like there are only 3 words possible. One is elate, the other one is plate, and the third one is slate. Okay, now this is what I want you guys to do. Next time we meet in class, come up with a reason. You guys are very good at that, right? So I'm late because, but there is a little constraint here. In your reason, you have to use these 3 words. Elate, plate and slate. And try to come up with the funniest excuse that you can ever make. Okay? So you have time until Tuesday. Let's get started. So we were discussing this example before. You know, I'm really very glad that you have started thinking in class, which is a very nice idea. This is what I would want you guys to do. All right, settle down. Thank you. So quite a few of you guys, in fact quite some of you guys had questions about the drawing that we were discussing yesterday. In particular, you know, so I had drawn an arc here, or fillet, if I may call, okay, and a fillet here, and many of you guys said, well, I mean, if there are two fillets here, then this actually happens to be a smooth surface, okay, and correspondingly there would not be any line here, here, and here. True? Right? Okay, so this was the doubt, no? So let me make, or let me propose a few changes in the drawing. Let me propose a few changes in the drawing. What I do is I let go of these arcs, I have a line, I extend vertical lines from these points, okay, and if this is the scenario, then do you think that I'll be getting the corresponding lines in the other two views? Yeah? So I'll be getting the corresponding lines in the other two views, okay? But think from a realistic viewpoint. Is it possible for you to manufacture an object with a 90-degree angle here and here? Yeah? Is it possible for you to manufacture this object with perfect 90-degree angles? Yeah? Yes or no? No. Realistically, there would be a little curve, okay? There would be a little curve here and a little curve here, okay? So let's draw that. A little fillet. It's probably not so discernible, okay? Just a little fillet, but the corresponding lines in the other two views will still remain, okay? Okay? All right. Any questions? Yeah? Tell me where are these lines? Can you show this model to me? Am I impressed or am I impressed? Well, I spent 5 minutes discussing this.
But I was not there. I was prepared.
Okay. You prepared this in 5 minutes? Okay. Almost 10 minutes? Not bad. All right, so just for your benefit, since you have worked quite hard, what I was saying was this was the initial drawing, okay, and in fact this was a question that was raised by you. So this is like a smooth surface, and correspondingly there would not be lines in the other two views, okay? Makes sense. Makes sense. But what I'm proposing is a slight revision. What I'm saying is, what if I let go of these smooth curves, have a horizontal line, extend the circular arcs, okay, through these vertical lines, and I get perfect 90 degrees. Then I'll have those lines. Why not? In this scenario, are we going to be having those lines? We will. We will, right? Now, there's the theoretical aspect and there's the realistic aspect or the practical aspect, okay? Practically, it will be a little difficult for you to make a perfect 90-degree angle. It will be difficult, okay? So practically what we do is, you'll actually be seeing surfaces like this, okay? Just a little fillet, just a little fillet, okay? But assuming that these two angles are 90 degrees, assuming that these two angles are 90 degrees in the front view, you will actually be seeing those lines. Slight revision that I proposed. Okay. All right, so let's get started. So today we will study first angle projection. All right, so you have done lab 2 with third angle projection. Okay, and this is example 3 in orthographic views of very familiar object, Victory Podium. Okay, let's recapitulate what we did in case of third angle projection. You had a plane in between you and the object. Okay, you imagined that there were light bulbs all along the edge of the object that emitted light along 3 orthogonal directions. Okay, so this was the plane on the right, again in between you and the object. On top, again in between you and the object. Okay, these are the lights. The light rays falling on the vertical plane, and this is what you would see if this plane was a photographic paper. This is what you would be seeing from the top, and this is what you would be seeing from the side. We have done this before, right? Let's consider the same object, but we will consider a different scenario. We'll say instead of the plane being between me or between you and the object, the plane is behind the object. So the object is placed between you and the plane. So this is the vertical plane that's behind the object. Okay, the horizontal plane is to be placed below the object, and the profile plane is to be again placed behind the object. Okay, all that has happened is the scenario has changed, the location of the plane has changed relative to you. In the third angle projection, the plane was in between you and the object. In the first angle projection, the plane is behind the object. Okay. Okay, and let's do the same exercise. Rays falling on the plane. Okay, what will these rays capture? What will these rays capture? The light bulbs are here. Okay, so these rays will essentially capture the loop that you see. Now note that the loop is coming from the front. The loop is going onto the plane from the front, not from the rear side of the object. Okay, once again. Right? So what's the impression that the horizontal plane is going to see? Almost the same thing. The loop is going to come from here, from the top surface of the object. This one and this one. Once again, it's coming from the top of the object. How about this? Okay. Right, so what's actually happening? This plane is capturing what you're seeing from here. Okay, this is what is happening actually. This plane is capturing what you're seeing from here. This plane is capturing what you're seeing from the top, not from the rear of the object, but from the top. And this plane is capturing what you're seeing from here. Right? Okay? Let go of the object, retain the impressions on the 3 respective planes, join these guys together, with that boom, tear this part off and unfold. Yeah? It's not from the other side. If this is the direction of your frontal view, okay, that plane behind the object captures the impression of the object as if you're seeing the object from this side. This one is from the top. This one is from here. Okay? So you need to be a little careful in trying to comprehend this. Okay, once again, join these guys together. Tear this part, tear this hinge, and unfold. Where is your front view now? Where is your top view now? Doesn't make sense, right? Top view at the bottom. Which view is this? The right side view. You were seeing the object from the right, so it's the right side view. Okay? Okay, so it's always a nice idea for you to get the concept so that you don't have to remember. And if you have to remember, then this is a very simple golden rule that I used to follow when I didn't understand this. In the first angle, the top is at the bottom of the front and the right is to the left of the front. Just the opposite. Okay? But this is the concept that's important. Be it the third angle projection or be it the first angle projection. You have been working with third angle projection. You have drawn the front view, the top view and the side view. Okay? Now can you answer this question to me or to yourself? Which of the three views is the most important? Which of the three views is the most important? Have you guys heard of something called FTP? FTP? File Transfer Protocol? Nah. That's the front view, top view and the profile view. So which one is the most important view? Front? Well, the choice is yours. But conventionally, we choose the front view to be the most important view. Okay, and having said that, what do? We choose the object or we choose the placement of the object in such a way that we are able to give as much details in solid lines, not hidden lines, in solid lines in the front view. What we try to do is we try to minimize, if not eliminate, the hidden lines or the presence of hidden lines in the front view. Okay, that choice is ours. Right? So the front view is the most important. Then the top and then the profile, hence FTP, front, top, profile. You know, I have never gotten somebody agree to me like that. Conquering with a song. Okay, why is this called the first angle projection? Why is this called the first angle projection? So if you imagine that your drawing is divided in 4 quadrants, Your front view, which is the most important amongst FTP, is lying in the first quadrant, and hence it's called the first angle projection. Why is the third angle projection called the third angle projection? There your front view is here in the third quadrant. Right? Okay, so let's draw this object in the first angle projection. Would you like to take 5 minutes to sketch or to try to sketch? Okay, now. So before you start sketching, this is the front view direction, and you have to rotate the object like this. Okay? So rotate the object like this and then view it from the front and then start sketching. 5 minutes. So if I were to ask you to describe this object, what would you say? If I were to ask you to describe this object, what would you say? It's a disc of some thickness with 4 holes mutually orthogonal to each other. Okay? And then there are 2 extensions which are, so to speak, semicircular, okay, with 2 holes. Right? A disc with 4 holes, and then there are 2 extensions or 2 appendages, okay, slightly semicircular in nature, each with 2 holes or 2 voids. That is not very difficult for you to imagine. Right? Take 2 minutes. You know, back in 1990, when I was in the 12th grade, we used to have this concept of the class monitor, right? So you have just graduated from there, from grade school to grad school. So our monitor then was Sanjay Tiwari, and we used to talk a lot. We used to prepare for our JEE exams, and we used to talk a lot. And he used to have a hard time. I mean, he used to come up with a list of many students disturbing the class. And he gave the list to my class teacher, and she goes like, Amit Raje, he was my classmate. And Amit Raje is like all perplexed. He stands up, yes ma'am. Why were you talking? Ma'am, I wasn't talking, I was thinking. Okay, sit down, don't think loudly. Yeah, so don't think loudly. Huh? Sorry. I didn't want you to sketch that box. Should we start? It's already 2:29, so I still have about 20 minutes. So let me get started. Okay, so start with your bottom right box. Fill out the details. This is the first angle projection. So your convention of representing the first angle projection will be different. Can you hear me back there? Am I discernible? Am I audible? So the convention to represent the first angle drawing will be slightly different. Again, truncated cone. Your front view is 2 circles, a set of concentric circles. What is shown on the left is what? Which profile? The right. Okay, so the profile on the right is shown on the left. So in the third angle projection, this guy was here. In the first angle projection, this guy will be here. If I were to draw the orthographic projections of this, how many views will I use? 2, 3, 1, 2. Why not 3? Why not 3? The third is the same as the second? Huh? Okay. So although we are practicing 3 views at this time, later on you will probably realize that in certain situations 3 views are redundant. At times just 2 views suffice. Okay. And at times 3 views are adequate. And at times even 3 views are not able to resolve the uniqueness in the object or uniqueness of the object. Okay. So we had seen that cube example in our second lecture or third lecture. Get this convention on the top right of the bottom right box. Place it down here. Let's get started. Using the scale 1:2, most likely I am going to be using the scaled dimensions, not the true dimensions. The first thing I would do is I would start with the bounding boxes. Okay. Once again, I have rotated this object like so, and that is my frontal view direction. There is no finish line. There is no finish line on your t-shirt. All right. What's the length of this box? Length of this box? What am I drawing there? Folks, what am I drawing? The front view. What's the length of this? The same as the diameter of the big circle, which is 124. 524. Right? What is the width of this box or the height? That is 10 plus 25, whatever this length is. How much is that? 25 plus 22. 25 plus? Okay, 25 plus 22 plus 10, 57. Good. Hinge line that separates the top view from the front view. Projection lines that come from top. In the top view, you are going to be seeing a circle of phi 124. Since you are making a circle, you have to locate the center. Okay, using 2 dashed dotted lines. I am showing this circle again using dashed dotted lines. Why is that? Huh? So this would bear the centers, the 4 centers of the smaller circles. Okay? You know, the circle is represented by PCD, pitch circle diameter. Okay? So hence I am using dashed dotted lines. Let's get started. Bottom line shows up. The vertical line shows up. This is of height 10. This line shows up. We complete this box. So this represents the front view corresponding to this disk, right? Extend the center projection line up. Now what am I doing here? What am I doing here? I am trying to draw these two appendages, na? They will essentially look like rectangles in the front view. You will be able to figure out the dimensions. So dimensions at this time not very important. Okay. So the height of course is 47 and the width is 25. Right? So this height is 47 and this width is 25. Is that right? No? Then locate the center of these through holes. Okay. They will be at the same horizontal and show the two holes using hidden lines, solid lines. Right? Am I done? What is this node? So I still have to sketch, or I still have to worry about these circles, na? Right? Okay. But before I do that, let me try to work with the top view. Bigger circle. Now what I have done is I have projected this vertical line onto the top view. From here, okay. So essentially in the top view I am looking at these lines. This line here, the line at the back, right? I know the length, I know that the object is symmetric about the horizontal axis. Okay. I draw 4 rectangles. Sorry, I draw 2 rectangles. Fine. And then of course the voids within those appendages. Fine. Now I am locating the 4 circles and the pitch circle diameter. I locate the centers and rest is straightforward. Once I have located these 4 circles, I can take the projections of these onto the front view and show them using hidden lines, right? Which is what I do here. Locate the centers of the 2 cylindrical voids and located the voids themselves in the front view. Right? So far so good. Am I done with the 2 views? Yes or no? Well, of course dimensioning remains, but I am not worrying about that as of now. How about the profile view? How about the profile view? Where will I show the profile view? Left of the front view. Left of the front view. So you remember, I mean, you're relating the top view with the profile view using projection lines and a 45-degree angle. Yeah? Do you remember that from this week's lab? How would you do the same exercise here? How would you do the same exercise here? Start taking the horizontal projections from the top view. Draw a 45-degree line, go up, and join the projections emanating from the front view. Exactly the same exercise. Okay, why? Because this dimension has to be equal to this dimension. Right? Once you have the bounding box ready in the profile view, start drawing. A disk will again look like a rectangle. Get the projections from these, if I may call, flanges. Okay. Get the center. Extend them. Extend the lines. Locate the center. Draw a semicircle. And draw the inner circle. Okay? It's okay. If you want to take a quick nap, it's fine. And then what? Relate that circle to the lines in the front view via construction lines. And of course the top view. And from the top view, get the projections corresponding to the smaller circles on the pitch circle diameter. Locate the centers and represent the smaller circles using hidden lines in the profile view. Okay? Of course, that's the top view. At the bottom of the front view, that's the front view. Which one? Right or left? Right. Okay? Any questions? Yeah? In the front view? Center of what? Because the cylindrical void is like so, na? So this center line represents the axis of the cylinder, axis of the cylindrical void. Right? One view is redundant. Why do you say that? So what you're suggesting is just two views are good enough for us to represent this object? You could be right. What is the what? Perfectly, perfectly. Conventions. Different people use different conventions. So some people are comfortable with the first angle projections, the other ones are comfortable with third angle projections. Can you stand up, please? What's your name? Ashish. Louder.
Ashish Agarwal.
Louder.
Ashish Agarwal.
Turn around. Come up. Stand by my side. So this friend of mine, Ashish Agarwal, he asked me when he was doing the second lab, sir, can I draw things in the first angle projection? He was so eager to draw this in the third angle, in the first angle projection. So I thought, why not? why not tell you all about first angle projection, so that just in case if he happens to draw in the first angle projection, you guys can all understand. So there are different conventions that people use. Yeah, please. Any other? Yeah. We don't draw dotted lines for smooth fillets. I didn't say that. You know, I have a lot of anecdotes to share with you. One of them goes like, when I was, when I was in the 10th grade, I was reading a book, and I read a quote by somebody, some character in the story, and I liked that quote very much. I am without politics. I am without politics. Okay? So please let me not behave as a politician here, asking you to be quiet every time. Okay? So if one of your peers is getting up and asking a question, please lend a polite ear to him or her, because then you will not be able to understand his or her question, nor will I. Thank you. I wouldn't draw, well, I didn't say that. What I said was, if I made that perfect 90-degree angle, then I will have a region of discontinuity. That means that two surfaces, they will be stitched together in such a way that you will have a distinct line, and that line is going to be shown in the other two views. Yeah. Well, any feature that gives you the impression that there is some discontinuity in surface, that is to be represented. Hold on. So keep that question in mind. I'll come back to you. We still have time, so I'll come back to you. Okay. Any other question pertaining to first angle projection? Yeah. Shouldn't the top view? Well, the choice is yours. So you can choose the principal view to represent the front view. The choice is yours. I chose the frontal view to be that. But you can choose differently. It's perfectly fine. Any other question? Okay. So just to emphasize, this is the what? First angle projection. Why? Because the front view is lying in the first quadrant. Okay, and in the third angle projection, the front view lies in the third quadrant. Hence the names.